Morning. I'll try and not bore you too much. And for my esteemed colleagues in the back who are struggling to hear me, please, there are seats at the front. So I'm going to do a quick intro to why the ecosystem's a wonderful thing, including all the bad bits. So for those that don't know me, my name's Andrew Wafaa. I'm one of ARM's software directors in the open source engineering group. My focus is on primarily communities, open source upstream, as well as some of the enterprise partners out there. Focus quite heavily on the operating systems. So I cover most operating systems. The only one I don't do is Windows. But I also deal with, like I said, upstream projects, upstream foundations, Apache Foundation, some of the Linux Foundation, as well as some of the commercial ISVs that base their stacks on open source. And for those that have been coming to Linaro Connect, I'm also known for having bad choice in party outfits. So, first things first, when we're talking about an ecosystem, what is an ecosystem? First time I heard the term ecosystem was when I was at school in biology. So an ecosystem is comprised of living and non-living things working harmoniously together. So you've got prey, predators, all working together in a physical environment. If you take any one of those components out, everything will break down. Taking out the small organisms that help with the decomposition of dead animal or leaves that fall into the ground, that affects the soil, which then affects plant life, which then affects the smaller animals, which in turn affects the larger predators. In a software or technical ecosystem, they are comprised of multiple communities. And there are generally 3 layers to an ecosystem. One of those is the core. Next one up from that, platform and tools, and then you've got your application layer. The core layer is generally comprised of a small number of key players that have authority, knowledge, and the drive to start building around that. On top of that, you then have the platform layer that is the glue between those core components and the application aspect. And obviously the application is the delivery of what the ecosystem set out to do. A simple way of looking at it is with an operating system, and in effect an operating system is its own micro-ecosystem. You've got the kernel at the base, you've got your tool chain, and then you've got your user application on top. So it's a digital community interacting components and their physical environment. As you can see, we've got multiple communities within there. We've got multiple companies, some are large, some are small, and together they work and deliver the ecosystem. So what exactly is ARM's ecosystem? Our ecosystem is literally from the small end sensors all the way up to the larger server side. You saw Linaro from Microsoft earlier. They are definitely on the larger end. We've got the smaller end of wearables, Bluetooth sensors, etc. And our ecosystem comprises of every component through that stack, including the network aspects. So ARM and our partners have been working quite diligently over the last 5 to 7 years, enabling that ecosystem through multiple means. And Linaro is all about enabling the ecosystem to deliver. ARM focuses on the key building blocks, so the IP aspect of it, ensuring that that works from a software perspective. Our partners then build upon those initial components, adding their own IP blocks in, and ensuring that the system as a whole works together. And both ARM, Linaro, or should I say both, ARM, Linaro, and our partners work collaboratively to ensure that all these key software projects that we all rely on can then work on there. So as an example of some of the components from the IP layer, we've got enabling the IP within the Linux kernel, and the trusted firmware, getting the OS vendors enabled, working on some of the projects and communities that sit on top of the operating systems. As an example, in the storage space, Ceph, we've got enabling languages like Java, OpenJDK, Golang, list goes on. And then you've also got the network stack being enabled in there. And with Linaro, they've got multiple groups. I've only listed 3 here, but they've got groups that are focused on enabling key communities and micro ecosystems to build that larger ecosystem at large. So that's great. We've got ecosystem. It's all enabled. So what are the bad bits? Take back to that slide. Physical environment tends to be the biggest issue at the moment within the ecosystem. So does that mean we need fully open source hardware just like we've got fully open source software? When I say open source hardware, I'm talking about having PCB layout designs, RTL available, mask layouts, instructions for printer, 3D printers if you want to build your own, whatnot. It'd be nice to have, but I certainly wouldn't say it's a necessity for the ecosystem. Because we've got 96 boards. All's good. They're close, but not quite there. In their defense, they've got a common design across platforms, which is easy. You can take peripherals from one board to another, mezzanines, etc. They're relatively low cost, so it's easy to get the hardware in your hands. And there's quite a large supply chain. You can buy them from multiple distributors, multiple outlets, etc. Problem is, a lot of the software for 96 boards isn't quite upstream. Most of it is, but there are key components that block easy adoption. They're not necessarily standard components from a developer board perspective. You've got 2.5mm power adapters, you've got odd form factors, and such like. Saying that, they work fairly well. If you just want to get your software up, you're not necessarily bothered about the full stack. You want a developer board that you can just power up, run an operating system on, and then develop against. They work really well. So I had a little bit of a negative point there. Don't like ending on a negative, so there is hope. That hope was announced about just under an hour ago by our friends at Cavium. The ThunderX station has just been announced. Linaro have been working with Socionext on a desktop platform. So light is near the end of the tunnel. We're almost there in ensuring that developers within the ecosystem can have a native environment that they can use day to day for both their work and their play, getting the code there, and it's all good. You've also got the Windows 10 machines coming out powered by Qualcomm from multiple vendors, whether it be HP, Lenovo, etc. That gives you another avenue to then do your development. So the ecosystem is healthy. It is moving leaps and bounds forward from where we were only a year or two ago. From an ecosystem perspective, we are very inclusive, which is a great enabler for the ecosystem. When we have to work with other architectures, they tend to be quite open with us, welcoming, so it's all good. Thank you, because I realise we're behind time, so I think I'd probably take a couple of questions, if there are any. Marvellous. Thanks very much. Oh, sorry, beg your pardon. I didn't see your hand.
So I think this ARM ecosystem, I think should have some kind of period, different stage and different period. So do you have any plan or some, the overview for the whole period of ARM ecosystem, and in different stage, what kind of things need to be resolved, and maybe the next step or even the step after 3 to 5 years, which stage will be like so do you have this kind of a roadmap for our ecosystem?
I do have a timeline somewhere. I haven't updated it in a while, but I can quickly go through that for you if you wish. So the first stage from ARM's perspective is ensuring that the IP designs that we come up with are enabled in the core components. So that's your kernel, your tool chain. And from there, you can then build out additional software aspect. The hard part of validating what those IP blocks look like within the software is the fact that we've just designed the IP. So 7, 8 years ago, there was no hardware. We didn't know what it was going to look like. So we had to do everything in models. Models are very, very slow. So it takes a lot of time to build your kernel, build your tool chain. Still waited on hardware for validating that, and the operating system vendors were waiting to be able to take what they had and try and build their distribution, build the additional packages needed. So they had to do it in hardware, in the models, beg your pardon. The advantage with the open source community is that there are a lot of very bright people, and sometimes they're also a little bit crazy. So as a hobby project, some people came together, they developed the emulation for the ARM architecture within QEMU. That enabled faster builds to happen in parallel with the models running on their slow speed. The QEMU emulation was able to do it at a slightly faster pace. ARM came out with some test reference platforms, which was great because it actually meant that you could see the software working on real hardware. That would have been about a year, 2 years, a year and a half after first code was there. And then from that, by that time, distributions had a full, minimalized, but a full stack that they could then test. And then from that, it was taking on the next stage of the software layer, trying to expand to a full distribution, all the different components. After about 3 years, first initial partner reference platforms were available, which meant that we had larger systems to do more work. By that time, we already had a full distribution, so it was a matter of adding the next layer of software, the middleware, if you will, trying to do the porting. There was a lot of time and effort was spent in ensuring that the software was architecture agnostic, moving that into a common area, so taking out things that are specific to x86, specific to power, making it uniform. And we're now at the stage of predominantly focusing on optimizations, making sure that the performance of the software runs as best as possible. So it's been about a 7-8 year period of actually having code getting there. The first 2 to 3 years of the actual announcement of the ARM64 architecture was very much marketing, getting the word out to different parties, to the communities, to commercial vendors, etc., ensuring that they were aware. That's hindered us somewhat because we were a little bit too early. But we're getting there now. Most of the software stacks work. Quite a lot of it works well. We're working on further optimizing things so that it ensures comparative performance with other architectures. The one downside is that there's always a new version of both the architecture and the different software. So in parallel, we're still having to do some enablement whilst we do the optimizations. Anything else? Thanks.